Hey, this is Mr. Ayton. This is Chemistry Honors, and we're going through some organic chemistry. We're going through some naming alkenes and alkynes today. We've gone through naming alkanes, those guys with the single bonds, those hydrocarbons with the single bonds, and so we're going to be moving on. We've learned how to name molecules like this. We want to know what's the longest chain that we have, and you can see the longest chain is this parent chain that I'm circling right here. And you can see we have one carbon, we have two carbons, we have three, we have four, we have five, we have six. So what is that called? Six carbons is called hex. It's all single bonds, so we call that hexane. And what do we have? We have two little substituents, two methyls. We have a methyl coming off here and a methyl coming off here. So we're going to call that dimethyl. And where are they coming off? They're coming off the second carbon and the fourth carbon. So that's called 2,4-dimethylhexane. We've talked about how to name these alkanes. If you haven't watched my video, make sure you go and watch my video on naming alkanes and naming even more complicated alkanes. But now we're moving from alkanes to alkenes to alkynes. And you can see that suffix, that ane, that ene, that ine signifies something. Ane signifies all single bonds. Okay, so you can see there's a single bond between the two carbons here. The ene signifies we have a double bond, and the ine signifies we have a triple bond. The good thing is it's in alphabetical order. Ane, A-N-E, ene, E-N-E, ine, Y-N-E. And so single, double, triple bond. Now I want you to see the chemical formula for these guys. We have CH3CH3 or C2H6. Remember, how did we do that kind of nomenclature? It was whatever number the carbon was, the hydrogen, we doubled that number and added 2. And that was if it was just a simple hydrocarbon where it's just ethane, butane, propane, pentane, hexane, things like that. Well, look at the ethene. If we only have one double bond, we have C2H4. So what can we do to that number of carbons? All we have to do is double it to find the chemical formula for a simple alkene. If we want to look at a simple alkyne with only one triple bond, I have C2H2. So what am I going to do? I'm going to take that number of carbons, I'm going to double it, and I'm going to subtract 2. So very similar to the ethane, but we're not adding 2, we're going to subtract 2. And that will surmise for my naming of simple alkenes. Okay, so now how do we name it if that double bond is not on the end? You can see there's no such thing as methane because there's no way to put a double bond anywhere. Now, there's only one place to put this double bond or this triple bond, and that is between these two carbons. But what happens if we have a butane or a propane or something like a hexane or a heptane, and that double bond is not off the first carbon? Well, we have some rules. Okay, and so I'm going to walk you through each one of these rules. Let's think about butane. What's butane? We have CH3, then we're bonded to CH2, then we're bonded to CH2, then we're bonded to CH3. We have 4 carbons. We have C4, and what's happening to my hydrogens? We're doubling that number, so we have 8 plus 2 is 10. We have 3 plus 2, 2 plus 3, that's 10. Now let's look at the butene. Butene. I know butene, it's going to be a simple thing, so it's going to be C4H8. And what am I going to do? I'm going to do CH2. I'm going to do 4 carbons like I did before. Okay, but that double bond's coming off that first carbon there. And now I'm filling in with hydrogens. Remember, each carbon needs 4 lines around it. And so you can see we're going to put 2 hydrogens there. There's only going to be the need for 1 hydrogen here because this carbon already has 1, 2, 3 bonds. It only needs 1 more bond. This carbon only needs 2 hydrogens because it already had that double bond, so that's 4 bonds. So if I wanted to do kind of the simpler formula, we have CH2, there's a double bond with CH, then CH2, then CH3. And that was my formula for butene, my chemical structure for butene. Now you can see this double bond was coming off what we call the terminal carbon, or the first carbon. We call that the terminal carbon. But what happens if it's not coming off of that terminal carbon? Let me give you an example here. Let's take a look at something like pentene. Okay, so we have 1, 2, 3, 4, 5 carbons for pentene. Now, if this double bond's coming off of this carbon right here, we can just call that pentene. We can just call that pentene. We don't have to, sorry about that. We don't have to do anything. We don't have to do any special naming. We can just call that pentene, and that will assume that it's coming off of that terminal carbon. But if this double bond is coming off of this second carbon, and we're going to fill in with all single bonds. And so let's fill in with our hydrogens here. We have hydrogens here. We need 2 hydrogens to make 4 bonds. We only need 1 hydrogen. We only need 1 hydrogen. And in the end, we have 3 hydrogens. Each carbon needs 4 bonds. So we have CH3, CH, CH, CH2, CH3, and you can see where was that double bond? That double bond was right here in the middle of that second carbon and that third carbon right there. And so what are we going to name this? Okay, there's 2 different names you can call it. Okay, you can call it 2-pentene, and so that 2 signifies where that double bond's coming off of, or you see it this way as well. Some people like to call this pent-2-ene. Okay, I kind of like that second one because it really tells you that that double bond's coming off of that second carbon. That ene is coming off that second carbon. The first one is totally fine as well, 2-pentene. Okay, that 2 is signifying where that double bond's coming off of. You'll probably see me write it more of 2-pentene, but there's always some people that write things different. You know, people are different there. And so let's take a look at this. Let's try to name these guys. We have 1, 2, 3, 4, 5 carbons. What's 5? 5 is pent, isn't it? And that double bond's coming off of the first carbon, so, and it's a double bond, so we're going to call it ene, and we're going to call it 1-pentene. Or you can just call it pentene, or you can call it pent-1-ene. Okay? Let's take a look at this. Now, this one you can see, there's a question. Where's our parent chain? Is our parent chain this 1, 2, 3, 4, 5, 6, 7? Or is my parent chain 1, 2, 3, 4, 5, 6? Now, you might, if you answer that question yourself, you'll probably say 8, and it should be the 7 because the 7 is longer than the 6. But in reality, our parent chain is the one I'm going to circle here. Why is the parent chain less than the longest chain? Is the double bond that trumps other things. Okay, that trumps everything else. That wins out, and so that double bond wins out, and so that's gonna tell me where my numbering or my naming is going to be. We want the double bond to be on the closest side, so we're not going to number it over here of 1, 2, 3. We're going to number it over here of 1. That's the second carbon, the third carbon, the fourth carbon, the fifth carbon, and the sixth carbon. So you can see how here we have 6 carbons. We're going to call that hex. Where is that double bond coming off of? It's coming off of the first carbon. So you can call it hex 1-ene, or you could call it 1-hexene. I'm fine with either one. And what do we have? We have a child, don't we? We have a little baby boy coming off of the second carbon. We have an ethyl group. You remember 2 carbons is ethyl? So we have an ethyl coming off of the second carbon. And so we're going to call that 2-ethyl hex 1-ene, or 2-ethyl 1-hexene. Either one is fine, but the double bond or the triple bond, that's going to govern where my chain is. That's going to trump everything else. That's going to trump any substituents that we may have that we've studied thus far. So let's try to name one more and draw one of these molecules. Let's take a look at this first one here. What's going to be my parent chain? Well, my parent chain is going to include the double bond. Okay, so my parent chain is going to include the double bond. And the double bond is going to govern where our carbons are numbered. So we got 1, 2, 3, 4, 5 carbons. What's 5 carbons called? That's pent. Okay, and that double bond's coming off of the first carbon, so we're going to call that pent 1-ene or 1-pentene. I'm okay with either one. We have a little substituent, a methyl group coming off of the fourth carbon, so we're going to call that 4-methyl or 4-methyl. So either it's 4-methyl pent 1-ene or 4-methyl 1-pentene. Either one is fine. Okay, so let's take a look at this next one. We have a pent. We have 5 carbons. This is how I like to draw it. I like to draw 1, 2, 3, 4, 5 carbons. Ene is coming off of the second carbon. So the double bond's coming off of the second carbon here. We have a methyl group coming off of the fourth carbon. So the CH3 is coming off of this carbon. Now I'm going to fill in with single bonds, and now I'm going to fill in with hydrogens to make 4 bonds on each carbon. And so 1, 2, 3, I only need one more hydrogen there. 1, 2, 3, I only need one more hydrogen there. 1, 2, 3, I only need one more hydrogen there. And we have a hydrogen here, and a hydrogen here. And so that's the structure for 4-methyl 2-pentene. So let's move to what's called geometric isomers. Sometimes these double bonds, you can see we have butene. We have butene that looks very, very, very similar. We have the same exact chemical formula, but a different molecule, and that's what an isomer is. Isomer means the same, mer means molecule, and so we have the same molecule, but they're different because you can see how they're structured differently in that the CH3 groups and the H groups are in different places of the molecule. Now you might say, Mr. Aiden, if I drew this in a straight form, I wouldn't see this difference. That's correct. But we know things aren't two-dimensional in real life. Things are three-dimensional. And so when the CH3 groups are on the same side, they're called cis-2-butene. Okay, the double bond's coming off of the second carbon. When the CH3 groups are across from each other, they call it trans-2-butene. So when they're on the same side, they are sisters. Cis-2-butene. Anyway, if they're across from each other, they're trans. Trans means across from, okay? And cis means alongside of. And so you can see where they come up with those names of cis-2-butene and trans-2-butene. Those are geometric isomers. So we're going to finish out by drawing some of our triple bonds, okay? So here we have pent-ine. So we have 5 carbons, 1, 2, 3, 4, 5 carbons. So I'm going to number them first carbon, second carbon, third carbon, fourth carbon, fifth carbon per se. You can see the triple bond, it's an ine. The triple bond's coming off of the second carbon, so 1, 2, 3 right there. We have 2 methyl groups. We have dimethyl coming off of the fourth carbon, so we have a methyl group coming off here. We have a methyl group coming off here. And what am I going to do? I'm going to fill in with my single bonds and my hydrogens to fill in 4 bonds. Now take a look at this second carbon. He already has the 4 bonds. The third carbon already has 4 bonds. We don't need any hydrogens on them. Same thing with the fourth carbon, and then the fifth carbon is going to have hydrogens there. Okay? So let's move to 3-octyne. Oct means 8 carbons. So I'm going to do B down here. We have 1, 2, 3, 4, 5, 6, 7, 8. The ine, the triple bond's coming off of the third carbon, so 1, 2, 3, triple bond's coming off the third carbon. Now I'm going to fill in with hydrogens. So I have CH3 here, I have CH2 here. I am already filled up in this third and fourth carbon. Then we have CH2, we have CH2, we have CH2, and we have CH3 on the end there for 3-octyne. Okay, let's take a look at this last example here, we have for C, we have one hexyne. Hex is 6 carbons, 1, 2, 3, 4, 5, 6. The triple bond, the yne is coming off of the first carbon, 1, 2, 3 right there. Okay. We have a methyl group coming off the third carbon, 1, 2, 3. We have a methyl group coming off right here. And now we're going to fill in with hydrogens. You can see how we need a hydrogen there. That second carbon's already filled up with 4 bonds. We need a hydrogen here. We need 2 on this guy, 2 on this guy, and of course 3 on the end. And that is 3-methyl-1-hexyne. So that was naming alkynes, double bonds, naming alkynes, triple bonds, and that is organic chemistry.